just focus on atoms. Whenever you see the word atom, not ion, atom, you know it's going to be neutral. By definition, it is neutral. So if you see the word atom, you know that protons are going to equal electrons. Sometimes you have to look at protons and electrons and decide, should I use the word atom? Is it neutral? And this is how you would do it. So you look at this picture here. I've got 2 protons. I don't care about the gray neutrons. I've got 2 protons and I've got 2 electrons. That means, I'm going to go with that line, protons equals electrons. They're equal, net charge 0. I would call this, 2 protons means it's helium. I would call this a helium atom. I wouldn't use the word ion because it's a 0 for a charge. Atoms are neutral. This next one over here, I've got 35 protons and 35 electrons. I don't care about my gray neutrons. They're boring. They just take up space. They don't contribute to charge. So 35, 35, again, they're equal, net charge 0. What element has 35 protons? Bromine. And I would call this a bromine atom because it's got a net charge of 0. The next one, I've got 12 and 12. I don't care about the neutrons. They're duds. They don't play in the charge game. They don't make purple. But the positives and the negatives cancel out, 12 of each. They're giving the whole thing a net charge of 0. This is magnesium. How do I know? I look on the periodic table for atomic number 12, and that's magnesium. And I can call this a magnesium atom. And finally, I've got the box from the periodic table, and I see that it's uranium with 92 electrons. So if I remember, that number on the periodic table, this atomic number, equals protons. So that means there's 92 protons and there's 92 electrons. Those are equal. They cancel each other out. I have a net charge of 0. This is a uranium atom. So you use the word atom whenever it's neutral. Now, if you don't know how many electrons, you can easily figure it out if you remember the word atom means neutral. So if you have this example up here, for instance, I've got 8 protons, 10 neutrons. I don't care about them. They don't contribute to the charge. They don't make purple. Only red and blue do. So if I have 8 protons and I don't know how many electrons I have, I can easily figure it out. If you tell me that this is an atom, then I know automatically that this has to be 8. You have to have 8 electrons to cancel out those 8 protons. If you didn't give me this picture, if you just gave me this box from the periodic table and you said how many electrons are in an atom of oxygen, I would say 8 because I know it's going to have 8 protons, and in order to be an atom, it would have 8 electrons. They have to be equal. Over here, if I don't know how many electrons and all I have is this picture, then I know automatically if it's an atom, protons have to equal electrons. If I got 19 positives, I have to have 19 negatives. Automatically, if you tell me it's an atom. Down here, if you don't give me a cute little picture with all the protons and electrons in there, I just have to remember that this number up top is the protons. And if this is an atom, then protons are going to equal electrons. So I would also have 19 electrons. So if I don't know how many electrons I have, but I have some of the information, or I have a picture from the periodic table or a periodic table itself, then I can just look at the atomic number and know that the two are equal. That's when it's an atom. The game changes when we call it an ion. Ion is different. Atoms are equal, ions are not. Atoms are neutral, ions are not. All right, let's compare atoms versus ions. Now, we already looked at these examples up here. Atoms are neutral. So if I have 12 protons and I have 12 electrons, then I know they're equal. Net charge of 0. This is magnesium, 0, and I can call it an atom. Now, the game changes down here. Ions. Ions means it has a charge. Everything else is the same. It just has a different number of electrons, and that gives it a charge. So look at this example. It's almost the same thing as what we just did above, but here we have 12 protons and only 10 electrons. That's not the same. There's more protons. So we're going to write in this top line here, there are 2 more protons and electrons. 12 versus 10, 2 more protons and electrons. So that's going to tell us what the charge is. I ask myself 2 questions. What are there more of? Positives, protons. How many more? 2 more. That's my charge. So I would write Mg plus 2, or Mg2 plus, whatever you want to write. Now, we have another word. We would call this an ion, but we have another more specific word that means it's not only an ion, it's a positively charged ion, and we call that a cation. Cations have a positive charge. Quick little way to remember that. If you see the word cation here, that T in the middle of the word kind of looks like a plus sign, and that makes you think it's positive. So cations always have more positives and an overall positive charge. All right, now, if we go back to this top example here, we see 35 and 35, protons and electrons, they cancel out. They are equal, and this has a net charge of 0. 35 is bromine, and it's got a charge of 0. It's neutral, so we call it a bromine atom. Not the case down here. Notice that everything's the same, it's just the number of electrons that are different. So when I compare protons and electrons, 35 versus 36, I realize they're not the same. So I can't call it an atom. I'm going to call it an ion. 35, 36, that means there's one more. I'm going to write in this box. There's one more negative electron than proton. 36, one more than 35. So what's my charge? Well, there's more negatives. How many more? One more. There's my net charge. So this is going to be bromine, Br minus 1. And another quick little way to remember anions are negative. They're the opposite of cations. This is an anion. I see the N there. That N reminds me of the N in the word negative. So N, negative. Over here, the little T makes us think positive. So if you have an ion that has a positive charge, it's a cation. If you have an ion that has a negative charge, it's an anion.